Okay, so this video is going to be over the chain rule for derivatives, and it is best to just jump in and do a lot of examples. The biggest thing you need to be able to identify is when to use the chain rule, and we use this when we have composite functions. So you might remember composite functions from college algebra. It's when you have a function inside another function. And so we're going to use chain rule by taking the derivative of the outside, leave the inside function alone, and then take the derivative of the inside. Another way that you could write this is you could make this f of u for your h function. And so h prime is equal to f prime of u. And then we will take the derivative of u with respect to x, or we'll take u prime if you will look at it kind of that way, which is a little bit more of this notation here, or Lebanese notation. All right, there's some strategies that we can use in order to do this. So let me go ahead and use that on this first one. So you want to identify what your outside and inside function are. So here, this is my inside function, and this is my outside function. And personally, I then like to say, like, okay, if this is u to the fourth, then its derivative would be 4u cubed. Therefore, h prime of x would have to be must be 4 times that inside piece to the third. That's what I mean here by 4u cubed. But then I need to take the derivative of u. So I'm going to multiply this by 6x squared plus 2. And that's the find g prime. And then we write it as that product right there. All right, let's go ahead and look at another example. I'm going to choose to rewrite h of x first as 3x squared plus 1 to the negative 2. Okay, if I have something to the negative 2 power, then its derivative is negative 2u to the negative 3. Therefore, h prime must be negative 2 times that inside g function to the negative 3. And then I need to multiply by the derivative of the inside, so times 6x. That means I would have negative 12x in my numerator and 3x squared plus 1 cubed in my denominator. All right, let's look at some trig functions next. Remember that this notation means sine of x and then cube. So if I have something cubed, its derivative is 3x squared. So h prime must be 3 sine squared x times the derivative of the inside. So in this case, that inside piece, right, is sine. So times the derivative of sine is cosine. Let's look at a little bit different variation here. Notice there's no exponent on the outside, so my inside function this time is 5x squared, and I'm looking at taking the derivative of cosine u. Well, that's negative sine u, and then I need to multiply by the derivative of the inside. So h prime in this case would be negative sine of that inside times the derivative of the inside. And I could clean this up if I wanted to. This one I didn't really need to clean up a whole lot, but this one right here, negative 10x sine of 5x squared, if I wanted to kind of pull that together. All right, we also need to talk about combining some of these rules. So now I have some inside pieces, but then I also have a multiplication. So I have an h of x that is sorry, my pen is not wanting to work right now. There we go. Okay, I have an h of x that is essentially u to the 5th times, maybe we say like v to the 7th. So the outside, actually the most outside function, we need to use product rule. So h prime equals the derivative of the first. I'm just going to write this out so we can see where all the pieces are going to go. Derivative of the first times the second plus the first times the derivative of the second. Okay, so I'm using product rule because the two functions that I'm looking at are being multiplied together. So I need to use that first. Then when I take the derivative of the first and the derivative of the second, I need to employ chain rule here. So h prime is 5, 2x plus 1 to the 4th times the derivative of the inside times the second plus the first times, and then my derivative of my second is going to be 7, 3x minus 2 to the 6th, and then times 3. All right, I can clean this up just a little bit by doing 10, 2x plus 1 to the 4th, 3x minus 2 to the 7th, plus 21, 2x plus 1 to the 5th, 3x minus 2 to the 6th. All right, on our next example, I'm going to choose to rewrite this again with this 4 kind of on the outside so I can see all the pieces. So I have cosine of 7x squared plus 1, and then all of that is raised to the 4th power. So now I have multiple inside functions that I'm working with. So the first derivative, the most outside function, is what I'm going to look at first. So k prime is 4 cosine cubed, and I leave everything on the inside piece like that. Then I need to take the derivative of cosine. So that's going to be negative. I'm going to go ahead and put the negative up here. Sine of 7x squared plus 1. And then I still need to take the derivative of the most inside piece, and that gives me 14x. All right, we also need to look at logs and exponential functions. So when you take the derivative of a log function, its derivative is 1 over u times u prime. A lot of times students try to do like a product rule here, or they think like the derivative of just natural log all by itself is 1 over x. But natural logs are composite functions, so this is that inside piece that I need. Therefore, f prime of x is 1 over x cubed plus 3x minus 4. And then the derivative of the inside is 3x squared plus 3. Exponential functions are also composite functions. E to the u, if I want to find the derivative of that, it's just e to the u, but then I need to take the derivative of that exponential piece. Notice in this one, again, I have a quotient between two functions, and that's my outsidemost function. So I need to take that first. So y prime is going to be low d high minus high. D low is just 1. That one's pretty easy, so I'm going to go ahead and do that all over low squared. All right, I have x times e to the x squared, but then I need to take the derivative of that, so times 2x. If I wanted to make this a little bit nicer, I could do so. I could have 2x squared e to the x squared minus e to the x squared all over 2x squared, and that could be my final answer.